right, so when we talk about buffers, a buffer, first of all, you have to know the definition of a buffer. A buffer means it's a solution that resists changes in pH. That's the whole idea. So if you add, let's say, HCl, which is a strong acid, right? A buffered solution would go from about 7 to about, I don't know, you had a little acid like 6.9. It's not going to change 6.8. It's not going to change very much. In unbuffered solution, if it's just water and you add some 1 milliliter of 0.1 HCl, it would drop the pH down to about, what does it say? About 3. pH is much lower. And that's what happens when you have an unbuffered solution. So the purpose of buffering is to prevent wild changes in pH, especially like in biochemistry where proteins can be affected by it. Same thing works with a base. I go to add a strong base, NaOH. If it's an unbuffered solution, I add 1 milliliter of NaOH, right? pH meter set at 7. That thing will go all the way up to, it's a little blurry, about 11. It's going to go up to 11, which is a huge swing in pH. Well, what if we did that to a buffered solution? We added 1 milliliter of 0.1 NaOH, it equals 7.1. pH is stable with a buffer. So the whole idea when we talk about a buffer is when you add, because you could add two different things to change pH. Acids change pH, they may go down. Bases change pH, strong ones. We don't talk about adding weak ones. But so the key thing is what happens there is it resists changes in pH. Now, a buffer solution, if you're going to make one, is going to be a weak acid, HA, with its conjugate base is the generic form of it. So HA represents a weak acid, and the A minus just means it's a conjugate because it's the negative ion. That represents a weak acid buffer solution. That's the one that they focus on in the AP exam. Just so you know, for college, you could combine a weak base, right? Which would be weak base, we would say we usually use the symbol B, and then the conjugate acid, which would be BH plus or B plus, whatever you want to say. But you could do a buffer solution with a weak base and a conjugate acid, which is a positive ion, is the other version you could do. Now, we talk about how to spot a buffer solution. You already kind of know how to spot a buffer solution because you know the cross-out ions. What you do to figure out if it's an acid, a weak acid and its conjugate base is cross out and a cross out ion. So look at A. Cross out ion I, cross out K, cross out I. The only thing I have left is H+, which makes that a strong acid solution. Because in order to have a buffer, you have to have a weak acid and its conjugate. There's only H+ there, which just comes from a strong acid. We go to B. Cross out ions cancel, 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 cancel. That's going to be a pH of 7. That's not a buffer solution because those are all cross-out ions. That's just going to be a neutral solution, basically salt water at 7. Read to C, I cross out Na, which leaves Cn minus and HCN, which there we go. There's our buffer because that's a conjugate base from HCN. The difference between an acid, a weak acid, and a conjugate base is going to be that single H that came off. And there you go. That's going to buffer because you need two components to a buffer. Last one real quick. Na is going to cancel. K is going to cancel. I just have a whole bunch of OH. That's going to be a super strong base solution is all that is. That's how we spot buffer solutions. Now, why do we need two components? Well, because we need two components. We need a weak acid. We need a weak acid and we need its conjugate base because it's almost like mopping stuff up in your home. You could use paper towel to mop stuff up or clean stuff up, wipe stuff up, or you could use a sponge. We have two components because acids cancel or mop up any bases. Because remember, acids cancel bases. What happens if you add a base? Well, acids will mop up any strong bases added. I said that wrong. Bases will soak up, like a sponge, any strong acids added. So it's like paper towel or sponge. You have a spill on your table. There's just two different ways to clean it. We have to have two different ways because there's two different ways you can change pH. You can change pH by adding. So look here, I add a strong acid. Well, what cancels out a strong acid is going to be the base, the conjugate base. So in this pair of, this is acetic acid written structurally, and this is its conjugate base because you see it's a negative ion. So there's my conjugate base. There's my weak acid. We could say HA and A minus. That's generally the thing you see used in like the review books, and sometimes on the AP exam they use that as well. And so that's why you have the two components. Just like if you add OH minus, what cancels out a base? You do the acid. That's where you see the acid canceling it out, and then you're going to produce